Hello, everyone. This is Dr. Tina Burns, and here is lecture 3D, or the fourth lecture in week 3 for computer architecture for the summer of 2025. I'm excited about being with you guys today, and let's go ahead and get started. So here's our roadmap for today. We're going to continue with our journey of assembly language, and what we're going to do is we're going to review some things about registers and commands, and then we will also look at some more examples and do some reverse engineering of the um, current code or current assembly language code. And then we'll also talk about how you access these items, which I went over briefly in another class, but I'll just review that here. All right, so let's talk a little bit about registers. So for this class, primarily, we will be working with the x86 registers. And here are some of the common things that you'll see. RA of X, that's typically going to be one of the first registers mentioned. And that is going to be where you return your values. So if you say X plus Y is such and such, where that value, where those things are combined, are going to typically be returned in register RA of X. Now, this particular item, you can modify that according to whatever your needs are for the program, and you store that as the user, as the programmer. Now, it can also be used in other instances to also store variables, but typically it's used for the return, right? Now, when we go down to these other registers here, we have kind of the items for the arguments. Also defined and called by the users and can be modified by the procedures. And then finally, we have these temporary arguments when we get down to our 10 and 11, which are just additional registers that you can keep and maintain for memory. Now, what I want you guys to note here, as we talked before, kind of are these RDI and RSI registers, right? Registration, the destination index register, the source index register, RDX and RCFX. We went over that a little bit briefly kind of in the other class, and we're still going to be using those registers today. All right, so let's go ahead and move forward. Now, we talked about, so you see how we have these registers here, the RDI and the RSI. Now, this is not, assembly language is not, it has a format, but it may not always follow the same thing. But I'm giving you guys kind of an overview of how it flows sometimes in a lot of code. You'll see RDI as the first argument, and then RSI as the second argument, and then RDX or RAX will be your result or your output. So your D, keep in mind, that is your first argument, that is your destination. So if you guys remember what I was talking about before, right? If I have something and I say add this to this. So if I say add, and then I have RDI, comma, RSI. If I have something like this, and then in some cases you might have a third item here, right? This would be kind of where your result or output is stored. If you don't have this, then the result or output is always going to be stored in that first argument, right? And we'll kind of see the differences between those as we kind of go through this code itself. All right, we went over this briefly already, where you have your different bytes and kind of what that means in terms of space and those items there. Q versus L, 4 bytes versus 8 bytes. And then these are some sample commands for that. All right, so we went through that. Now let's get a little bit more into the nitty gritty, and let's look at a bunch of examples here. So we have, before we go into that, keep in mind that when you're dealing with assembly language, you are looking and you have closer access to the registers. Now your registers are going to be near the CPU, and you can determine whether you want to store those values in the upper register or the lower register. So what you'll see here, this Q, of course, as we stated before, is going to denote 8 bytes of information or 64 bits of data. And um, what you're going to do is you're going to calculate this particular item and then you're going to store it in the address. So you're going to calculate whatever operation you want to do here, right? Which likely is going to be some sort of like add. You're going to calculate them between these two variables, and what you're going to do is you're going to store that in RD of X, right? If you guys remember what I said before, this kind of represents what you're seeing here. First argument, second argument, and then where you're going to store it, right? These two, you're gonna add them together, you're gonna store them here. That's pretty much it. But notice how the second command does not have 3 arguments, it just has one, right? And what you're gonna do for that, that means you're gonna move this information from one address to another. This is your destination index, right? This is your, or RDI, right? So that's gonna be kind of where you wanna move that information into for this particular item. All right, so as I stated before, this is your destination index. You're moving the value that is an RA of X into RDI. This is simple. We already talked about that. You're just jumping to whatever's labeled. If it's greater than a particular element, you're gonna jump greater than or equal to an element. You're gonna jump to whatever wherever the label L2 is. If it's less than or equal to this item, you're gonna jump to wherever the label of L3 is. All right, so there we go. That is that review there. All right, so let's look at kind of some of the values that we have here. If we have a long integer, we want to return some long value. This value is going to be the one that we return. So I would typically probably call this, RA of X. We'll see how it looks when we get the solution, but I'm gonna say our return value is that's probably going to be what's returned back there, right? All right, so I have my input, which is a pointer P. I have a long number here. And the first thing we're doing for this code is we're setting this long number X to a pointer here. And then we want to do some calculations here. Long Y is equal to X plus some sort of value that we have up here. And then we want to store that value of Y back into the pointer, but we want to return X. So again, the intention of this is to increment a particular number. So let's take a look at how that looks kind of in assembly language or machine code, right? RA of X, right, which is what I said before. Oh man, is it gonna let me move this down? Yeah, kind of looks a little. I'm just gonna delete that. Just gonna clear all that. But as I stated before, remember I said I suspected that that return value would be RA of X. Now the value we have here is going to be your first argument, right? RD of I. Notice how that is the destination index, and then you have RS of I, which is your value or your argument or whatever you want to have in terms of your value that you are changing, right? That's your, we'll call that the source, and you can use that both for the value of X and the value of Y. So let's go ahead and look at what's kind of happening here. If I were to do this, excuse me. Mm. If I were to do this by hand, all right, I already know what I want this to be. So the first thing I'm going to do is I'm going to set this increment that is my label, right? The first thing I'm going to do is I'm going to move all 64 bits of this of RX into my destination index, right? RX is what I'm already returning. That's already going to go into this destination index right here. Then I'm going to add this value to this, right? I'm adding RSI to this here, right? I already had that information there. I'm adding this to this guy, right? Adding this to here, and now I'm storing this into this particular value. Once I do that, then I can take what my destination index is and I can store that back into our uh store. Once I've added, now I basically have added these two information. I added this and I added that, stored it into my value there, and now I'm going to move this into where that previous value was. So what we have here is this, the parentheses here are going to represent a pointer. So I already know this is my p of x. I'm going to go ahead and actually change the color here to blue. I know this is p of x because this represents a memory address, right? So what do we think this is doing here? This is taking care of this first command here. Notice how p of x is my destination. So I'm moving my return value into this destination address or this pointer, right? This is what I'm returning. Now, I want to return, or I want to have the information I have here. This RSI, which I have already said is Y. Or actually, this is going to be my value. This is my value here. I'm going to add that to X. X was already in there. I'm going to add that to this and then store that into my return value. And then finally, I'm going to move this value that I had here into my destination index, which is that pointer argument of or I'm going to move that information into where I have my pointer. All right, so we know that this is our p of x, and we know that this is our value for these items. So what you'll notice is that before, when we were working with these items, our destination index was this first argument. This representation of the assembly code is actually a little bit different than what you may get in your debugger or your compiler. So for this particular instance, we actually have the source here and the destination here. So again, when I talked about the previous code, I will go back a few slides and then we'll return back here. I was talking about typically how you have your source in one direction and your index on the other. We are dealing here with the what we call the AT&T syntax, right? And the AT&T syntax, what it does is it puts, here is your source, here's your destination. So we're moving the value of p of x, or we're moving this value information here into our destination there. All right. So I move this into my return value. Now, since I have this in my return value, now I'm going to add this to, I'm going to add the information I have here. I am now adding these two items. I have my value at the moment, right? Which is what I input into here. I'm going to add that to X, which is currently in here, right? And then I'm going to go ahead and store that into RSI, right? So you can follow kind of what the source and destination is based on where it is in assembly code, right? You notice how it says, I'm going to put this here, then I'm going to use this in the next line. This is here. Now I'm going to do some operation. I'm going to put that here. I'm going to use this in the next line, do some sort of operation, and then I'm going to store that here. And then what I'm going to return then is the result of that operation. All right, so I'm taking X, storing it into my RA of X, taking X and Y, adding that, storing it into my RSI, which is the source here. I'm taking this from here, and I'm going to go ahead and store that into my pointer, and then I'm returning my pointer, right? So you're returning, you already know that your X is your pointer, so you're just returning that information that you just had there. All right, let's look at another one. Okay. Ooh, a recursive function. What fun, what fun, what fun. All right. So we have this long integer, which is going to be a 64-bit item that is returned. And then we have our function here. We're going to go ahead and just set this up as a label. Right, p count. We already know that's going to be our label. All right. Now, here is a particular item here, right? I have this, I know what I'm returning here, and I have this based on a value, right? If we say R, our X is going to be more than likely RDI. RDI or RSI. If that is equal to 0, then I'm going to return 0. If it's not, then I'm going to go ahead and take the end of that and add that to itself. So keep the, oh, so sorry. Wow. It keeps on moving these items back and forth in order to get the value that we want, right? This is already telling us kind of what we have here. We have, we're going to move 0 into our output register, right? This is our, what we're returning, the A of X, right? Keep in mind that that signifies what we're returning. I'm going to test or determine if this is equal to these particular items. If it is equal, then I'm going to jump to L6. For this particular item, this L6 is where I'm returning, that's here. If it's not equal, so this is this item here. This is my label 6, which is just a return. If that's not the case, then it will perform the rest of these actions, right? Where RB of X is excuse me. We already know RD of X is our X value, RD of I is our X value, right? That's the item that's here. This push Q means I'm pulling this information from the stack. So I'm moving RDI into this register that I've just taken from the stack, right? Take this from the stack, store that into this register. Then what I'm going to do is I'm going to add 1 to my output. Or I'm sorry, not adding it. I'm performing the AND operation. All right, keep in mind that your L indicates that this is a 4-byte item, right? This one is using all of it. This is taking all 64 bits or 8 bytes. This is only using part of that register. It's ANDing this 1 to the value that was already stored here. And if you remember from the last class, right, both of these are L. This is only using a portion of that A of X register, which is also why it's E. All right, so we have that. We're taking this, we're adding the value of 1 to our previous value here, and we're storing that into EB of X. Then the next thing we're going to do is we're going to perform this operation that is here. This is performing our shift operation. So it is shifting the value that we originally had in our d of I, right? It's shifting that information by a particular item. Then I'm calling this function of p count. Once I call it, it's shifting this value of x by 1 or shifting it over. I'm going to add RB of x and RA of x. Remember, RB of x is now our x value. RA of x is what we previously had stored in that item. And then I'm going to pop it or push it into the stack. I'm pushing this guy into the stack. And that is this full operation here. All right, so let me just clear that. So again, this first action, this first item here takes care of these, right? Where RD of I is my X value, RA of X, excuse me, is my return value. And I'm saving all this information, my response into RB of X, right? That's what we see here at the last line. When we have these recursive functions, I already said that, right? I already talked about how this is a recursive argument, right? This is going back and forth. The RB of X, this is kind of where we end this information. RA of X is what allows us to call back into that original function. RB of X is then what we're using to add and to store that information. And then we have our response here. All right, so I do want you guys to kind of remember a couple things, important things from this lecture. And that is you want to follow the assembly code to see which representation you have, right? Whether it's following the AT&T structure or it's following the Intel structure. This one is the AT&T structure where you have your source on your left and then your destination on the right, right? You can tell that easily by just looking at that. It's moving a value into this, right? So now I know this is my source, this is my destination, right? And it'll be easy to tell kind of where that item is because we are looking at the values that are in this particular thing, and it's going to follow whatever it starts with, it's going to end with. Then the next thing I'm going to do is I'm going to test this. I actually believe that this should be RSI. I'm not sure these both should be RDI, but whatever the case may be, I'm testing these and I'm comparing them. If they are indeed equal, then I'm going to jump to this item here. Same thing here, right? You're adding this and you're putting that value into EB of X. You're moving this into the destination index into this RB of X, right? So keep that in mind. That's how we're doing it here. Now, when you do your programs on Linux or on the iLabs machine, it's gonna be reversed because they use the Intel format for the GNU radio items, which means that your source is gonna be on the inside, right? So keep that in mind, right? All right. So here's one thing that I'm really excited about, and that is reverse engineering a code, right? If I were given this code, tell me what if I had to, I want to get this back into this format here, how do I use it? So before we even start, let's look at kind of the kind of format that we're looking at. A of X, that already tells me that this is I'm storing this somewhere. This is my output. When you have X, right, that means A of X, B of X, those are going to be my return values or where I'm storing the information in. So I already know that I'm taking these. This is my source. This is my destination. So what I'm doing is I'm performing an operation on these two items. And what I'm doing is I'm storing the result into this space right here. All right. So my long value is going to take two of these items and store them in a particular instance. And by the way, you can go ahead and find this at I pulled this from this YouTube channel here, so you can feel free to go ahead and watch that video as well to give you a little bit more of a deeper reference to what we're doing here. I'm going to make sure that's blue. Great, it is blue. Okay. Uh-huh. All right. So now I have my three values. It is basically saying I am taking all X, Y, and Z. I'm adding them. I'm storing it here. So if we assume that this is X, we assume that this is Y. We assume that this is Z. I store my items there. Now, that is kind of this portion of information that we have right here. I want to store these values, X and Y. I'm taking this and I want to save this into this output here. Then I want to add RD X to it. So this is actually my Z. I want to add RD X to that guy. So this is X and Y. I am adding these two, store them into this register RE of X. Then I'm going to add these, and then so I'm taking this and then adding it to A of X. And what I want to do is I want to compare those values. I'm going to compare this to -3. I'm comparing this value, whatever is in RDI, to -3, right? I'm comparing my value in RDI to -3. So what that looks like for us is if this is less than, if X is less than -3, I'm going to perform some sort of operation, right? Keep in mind, here's our X. X is RDI, our Y is RSI, right? And we're going to call our Z RDX. If I'm going to compare them first. And this says I want to look for it to be greater than or equal to. So if I have this, I'm actually going to back up. Here's what I know. This tells me I'm using X, this RDI option here. This tells me that my value that I'm comparing it to is -3. The next line tells me what I'm looking for when I do this comparison. So I want to compare X, and I want X to be greater than or equal to -3. Another way to say that is 3 is less than X. I'm sorry, another way to say that is X is less than 3. So again, we have our value here. We want to compare it. -3 is what I'm considering. And I'm like, hey, is -3 greater than or equal to X? Or I'm sorry, is X greater than or equal to X, to that value? And then this will tell us kind of what we're looking for there. So That's how we get this second line of code here. This greater than or equal to is the same thing as saying less than, right? Because x is, if I say, if I want to move this in this particular instance, if not, then I'm going to perform some other action. If that is the case, then I am going to jump to L2, which is this, or actually that's going to be where I do my return. L2, I'm guessing is this, where I compare RD of X, which is Z, and RS of I. So let's look at these two. When I did this initial function here, my comparison was on the outside, right? My -3 option was there. So I'm going to follow that same format here. I know that my RD of X, as we said before, is going to be the C value. And I want to compare that to my RS of I, which I believe is Y. And then the next thing is just to look at what that comparison is. And again, that's greater than or equal to. So I believe that this is also a less than sign. Yes, awesome. So that's one action, that's one item right there. So again, if you follow that, already know that this is going to be on my right side of the operand, right? First value is going to be here. The RD of I is going to be on the left side. And then I want to do the comparison algorithm here. So I follow that same format for here for Y and Z. All right. If that's the case, right, then I am going to jump down to here, right? I'm not going to do that yet. Let's handle the next line of code. If that was the case, then we would jump to this layer, but I don't want to jump to this label right now. I'm doing some action here, moving RD of I to RA of X. So what do we know about RA of X? RA of X was our value here, where we basically had all three of those combined. So that's telling me that if this is less than Z, what I'm going to do is I am going to move my output into my value. So again, RD of I, the last time we had that was here. So that means my value should be all this is doing is it's taking my value of, let me write this out again just so I remember it. This is X. It's taking my value of X and it's storing it into R A of X. Oh, okay. All right. So, all right. It's taking X, storing it into this value, and then you're multiplying X and Y. So that's telling me that my value or what I'm returning is going to be X times Y. Right? I'm taking X, I'm storing it into R A of X, and then I'm taking Y, multiplying it by that, and that's where I'm storing it. Now we jump down to level 3. Remember we said if this is the case, we're going to jump down to level 3. Or L3, which is our label. And then you're going to return. Else you're going to do this value that you're going to return it. Else, which is this layer here, I'm going to move Y into RA of X. And I'm going to multiply Y times X. Oh, I'm sorry. I'm going to store y into a of x, and I'm going to multiply z times a of x, right? So now this becomes uh, z times y. This was x. No, this was y times r a of x r di x. Okay, this is x times y. This is going to be z times y. And then I'm going to return it. So one of these is going to give us an x value. One of these is going to give us a y value. The other condition, right, this is from back up here, meaning if it's greater, if x is greater than -3, then I'm going to perform this action. Our layer 3 is telling us we want to compare this. All right, 2 is going to be our value that we compare. So we're going to go ahead and say 2 is going to be here. And what we're comparing to is RDI. Our RDI is X. We already know that. So we're going to say if X is, it says less than or equal to here. So we're going to go ahead and change that to greater than, right? Because we want kind of the opposite here. If that is the case, then what we're going to do is perform these options, this layer level L4 label here. If not, let's go ahead and move this. We're moving RDI. RDI is our X into our return value, or A of X, or D of X. We already had that as Z. So we basically multiplied Z and X. And that's pretty much the code there. So let me go ahead and clear this. And let's get the actual kind of things going through. So as you guys see, you kind of see this where we were at this action here, y and z. So if y is less than z, that's going to be our comparison here. I believe our d of x, that is our z. Yes, our d of x, this is our y. So we say, hey, if y, our d of x, or our side, y on this side is less than z, this is what we're going to do, right? So we have that correct. X times y, that's going to be our value, and that is based on this multiplication here. Notice how this is our value for it. We stored the x in here, so this is x. And your direction is going to be important as you kind of go through these items here. This is X. RSI we already know is Y. I already said that this is kind of going to be your destination. So this is X is going to be on these two items. You're going to multiply X times Y. All right, the next one is going to be Y times Z. That's going to be these items here. If you guys remember this particular one, this is going to be our Y that we're moving into this one, right? So now we have y here, we have z here. Very simple. All we're doing is saying, hey, y times z, and we're multiplying them. And then else, now we're going to compare these two. Again, comparing 2 to my RDI, which was x. We already knew that, right? And right now it says I want my x to be less than or equal to, but because these are kind of reversed, you're just going to use instead this kind of greater than sign here to get that value. Right, greater than 2. And then finally, our actual value is when we get to this final layer before we return, we're moving x into our output, we're taking X, we're multiplying that by Z, and that's our final number. So hopefully that made sense. The more you do these items, the more sense it will make. Other than that, this will cover kind of how you can deconstruct or reverse engineer some of this assembly code that we've been looking at. We also want to look at different ways where we can access this code, right? And you're going to need that for your bomb lab, right? So we know how to, if we're looking at this basic, assembly code, we have a somewhat of an idea of how to decipher it from maybe from our source code. But from the source code, how do we get to the assembly code? Well, let's take a look at that. There's a few ways we can do that, and we'll go through a bunch of them. Let's look at this conditional move example, and let's go ahead and implement this in a C file. So again, I'm going to use mobile Xterm to gain access to C and to implement part of the code. You can use whatever you choose. Give me a second while I log into that. And I'm also going to log in here. All right, so I'm now logged into these. Okay, I didn't like that. Let's try that again. All right, I'm gonna go ahead and make a folder here for what we're doing. Let's log into our class. And then I'm gonna go into 2025. Okay, make the art, and we'll call this week 3D. Oh, I have a folder for this already. Let's see what's in there. Okay, we just have our make file in there. So let's go ahead and open our make file. All right, and let's go ahead and log into that again. All right, we have that here, and we're going to do it one more time for our other options here. Teaching CS211, 2020, week 3D. All right, I'm going to clear this just so I'm at the top. All right, and let's go ahead. We're going to go ahead and generate this code that we were looking at here, where we have a conditional move example. We're going to take in two inputs and then return the result as an output. Relatively simple code. Let's go ahead and write that out. And we will call this nano condition move .c. Okay, of course we know we're going to have to include our libraries. All right, again, I always start off like this so that I have comments. Int main return exit success. Print f. This is a conditional move example, is what we're going to call this. All right, we have that. Let's make our conditional move function here. And we want to return a long. Oh. Actually we're gonna make this absolute difference. Okay, so we'll return a long, we'll call this abs diff. Again, all I'm doing here is just creating code for my program here. Long X, long Y. And I want to make a long integer called results. I don't know if I want to call it all right, fine, I'll call it result. If so, I want to say if X is greater than Y, um, we're basically going to return X minus Y. Now, all we're doing for this program is we are creating result is X plus Y, excuse me. All we're doing is we're creating a program here to give us the absolute value of a number. Else, of course, this is our case, result is going to be equal to Y minus X. That's going to be what we return there, and then we are going to return result, right? Let's go ahead and save that. We just saved this file. This is our main function. And what we're going to do here is we're going to call that particular function. Um, and we're going to print that out. So we'll make a long here R, and we'll call R is going to be equal to absolute diff of two numbers, and we'll make the two numbers 5 and 6. And then we're going to print F. We don't have to do that. We're going to do this just for R, because why not? Um, and what I'm also going to do is just so that we can see this a little bit clearer, I'm actually going to break this up more. And this is for a purely representative fashion so that we can see how the code is kind of broken out when we look at it in our windows. All right, I'm going to save that here. I'm going to try to execute this guy. Print let's go ahead and print this function here. I believe the print function is, we'll find out. Absolute difference is, I think this is LU. We will find out shortly. And then this is going to be R. Let's go back to our make file here. And we're going to change this to conditional move, because that is what we call the VI, I believe. Well, let's see what we call it. Yes, conditional move. All right, so we have this here. Let's see, we're gonna make it course, we have some errors missing. Oh, well, that's a simple one. Slight spelling error in one of those results. All right, so let's go ahead and save that and make that. Okay. Oh, that I forgot to put the number in. Well, I have two values here. Looking at it long, we're putting in the numbers. A, B, S, D, I, F, F. First thing we got to do is make sure we close this bracket out. Okay, that is our program. Let's go ahead and move this. And we'll see that the value is 1. I'm going to add a end of line character here. All right, again, I know this is taking a little bit longer than I expected, but again, we're just doing this to create a very simple program. Let's change our number up a little bit to 20. Make that execute it. We get 15. That's the value we want. Okay, so here's our code. Again, this was implemented from slide number 20, slide number 20 on your in your programs. And you can go through and see this is one way to kind of look at that code for absolute difference. So we're going to compare this with what we get when we output that guy from different in different aspects, right? So one way we can do this, right? We have our code here. If we look at the screen, we have our conditional move.c, and we also have our conditional move.out and the make file, right? So one thing we can look uh, one way that we can examine this code is by using outputting this. We can access this assembly code by using a command from the compiler that will create a .s file that will have your assembly code, and you can look at that as a text file. So let's try that way, right? And the command for that is going to be gcc-s, and then your executable file name. Okay. Uh, all right, I'm getting a slight error here. Let me figure out why. So sorry. This should be your C code file name, not your executable. My apologies. Your C code is used for when you want to get the assembly code. Your executable is used when you're working with GDB. All right. So now we have that. We have this new file that you'll see that was created here, this conmove.s. So let's go ahead and open that. And you can read that with the regular text reader. So we're going to use nano. We're going to open up that file, and you'll see this gives us our assembly code here, right? So we now have this portion where we can kind of see our assembly code and what it looks like. Absolute difference is the function that we were looking at previously, right? This is the function that we just created. Let me go ahead and make my screen a little bit larger for you guys. Okay, I have my absolute different function. And if I were to put this kind of side by side, let's put this side by side with the code. Let's make this a little bit smaller here. This is my original code. So here's my absolute difference, right? Here is the label that we're going to use for this LFB6. And then you'll see it has different labels for your conditions, right? L2, L3, and then LF E6, where it's going to be calling all this. But what we're concerned about here is primarily this function. We're going to see that it starts a process. It's going to push this RBP out to allow you to have a register to store that information. And then it's saying, hey, this is the offset for your numbers where you want to store the data. And then the first thing it's going to do is it's going to move some information into with this queue, which is going to give us 8 bits of information, is giving us data or moving it so we have registers for RSBP, I'm sorry, and RBP, right? So we have that. Now, RDI is going to be one value, and then RSI is going to be the other value. Now, we know from before, we were basically saying that your one is going to be your source index, one is going to be your destination index. Now, this tells us these numbers here are going to denote where at what position of the register this is stored in. So this is taking one register, RBP, and it's storing both of their values in there at different points of this. So basically 8 bits after that, it's going to store this other item for that, right? So both of these RBI or SI are going to be stored at these positions in that register, and then I can go ahead and access it. All right, so we will say that this guy is going to be our X. This is going to be our Y. Oh man, that is really, really messy. All right, so I'm storing this as my X value. I'm storing that as my Y value. And then the next thing I want to do is I am now going to go ahead and move my X value into our A of X. All right, moving your X value into our A of X. The next thing you're going to do is you're going to compare, right? I'm comparing X to Y because that is my second element, right? I'm comparing X to Y. And I want to say if X is, so these are our comparisons here. And I basically want to say, hey, if I have a value where X, I'm listing this as X is less than or equal to Y. In other words, or Y is less than or equal to X. In other words, as long as X is greater than Y, then I'm going to jump to L2. Now, L2, as we know, is this operation right here, right? If I were to jump to L2, well, let's not do that. X is greater than Y, I'm going to jump to L2. If it's not, what I'm going to do instead is I'm going to move my Y now into my registry index. I'm moving Y into this space right here. No, I'm sorry. Assuming that it's not greater, I'm going to move Y is not going to, my original number then is going to be X here. And what I'm going to do is I am going to subtract Y from X. And I'm going to store that value back into this, and that's what's going to be output. The other condition would be that if my value then is, if X is greater than Y, then I'm going to jump down to here. And in that case, I would store Y into my the y into this index that I'm using, and then I'm going to subtract x from that. So this becomes my y minus x. And then that is going to be what I return, right? So then that says, hey, I have this. Now my value is y minus x. And then the next thing, which is L3, is going to push this out and output this to the stack. So that's basically it. That's how we view it. This is how we look at it. And now we have a better understanding of what we're doing here, right? So here, super simple, move X into here and move Y into there. Once we have it in this register, you're going to do some comparison here, and then you're going to output here. So it looks like this representation as well is similar to what we were looking at in the slides, where this second this one on the outskirts is going to be kind of what your destination index is, and the ones on the left are going to be where your source index is. All right, so that explains how we did that, right? And we see that code here. If we were to, I'm going to go ahead and clear this guy all out. If we were to go down a little bit further, we'll see the additional information from the file, right? Our string where we had that, this is our conditional example, the string where we had that, and then of course our main function where we're inputting all of the data for it. I'm not going to go through that today because what I wanted to focus on is just kind of how we can view that main code for this. So this is going to look very similar to what you guys saw in slide 21 in terms of that data. Now let's move on. So this is one version, right? Now let's move on. I'm going to reattach this window. And I will show you guys another way where you can view this, and that is using GDB. And you remember from the last class that GDB stands for GNU Radio Debugger. So let's get out of this guy. And let's open up a debugger window. Now, keep in mind, if you are opening it from the compiler standpoint, you would open the compiler. That gcc-s command is going to be using the source file, which is your C file. If you are opening it from the GDB, your GDB is going to be looking at the executable file. All right, so we're going to go to GDB. Now, from the old code, we're gonna put this in just to avoid some of the errors that might come up from the from creating this guy. And then our file name. Uh okay, so now we have our conditional move out here. So I'm gonna do a couple things. I'm gonna do layout next here. And I'm going to parse through that a couple ways. The first thing is going to give us is this assembly code. Now, this assembly code is very similar to what we saw before. Now, the way that GDB is going to do it is for each function, it is going to tell you the line and the information for that particular function. So this absolute difference is giving you all the information for that function here, right? But we see a similar pattern here. It's going to push this into the stack, meaning now this RBP is ready for you to use. And then it's going to remove, I'm not sorry, not remove. It's going to move that first response into this RBP. And then it's going to kind of push out this as well to have something available for that. So you have RBP ready as a register, you have RBX ready as a register, and you also have RSP too, right? Then it's going to say, okay, I want to store X into RBP at position 28. and I'm going to store RSI into this at position 30, right? Now, this is just it looks a little bit different between this and S, but you'll see it's pretty much going to be the same kind of representation, and it's storing it on the upper half and lower half of that particular register. Now, notice how it says, okay, I'm going to take this value for X, I'm going to store it here. And then what I want to do is after I move it, I want to move then these values into my return register. Now that it has that there, I've moved this here. I moved these here in the these two registers. I can go ahead and compare. So I move this my RBP at 28. I move my X register into this. Now I'm going to compare my X and my Y. And if it is less than or equal to, or in this case is X is greater than Y, then what I'm going to do is I'm going to jump to what I call this absolute difference at 76. So the way that for GDB, it will tell you the line that it's jumping to. Whereas when we look at the S file, we were seeing it give it in labels. So this is going to tell you the line to jump to. So this is saying go to this line right here, right? Or in other words, oh, sorry, I went up too far. I went up too far. If you get that, you're going to jump to this portion where you have 1255 or this right here. That's the line of code. So it would give you the line you're going to jump to and the position that it is in that function. All right. Now, if it does not meet this condition, then now I am going to move. I already have this RA of X, right? I have moved X into this value. The next thing I'm going to do is, if this is not the case, what I want to do then is I want to subtract Y from X. All right, so that's what I'm doing right here. I'm subtracting the number. And then I'm moving this output into my return function here. I'm moving this, the Y minus X then moves here, ready to be output. Now, our next line of code is talking about I did this initially. So, right, if we look at our code here, this was the initial one. This is going to be something where we look at this particular portion, J and O. All right, this is going to execute this. This J and O means that you want to execute this if there was not an overflow from the previous condition. But it also accounts for our else statement right here. All right, so now what we're going to do is we're going to move Y into our output here. Y is in this position. X is in that position. We kind of switch them around. And now, or I'm sorry, Y, we're moving into R D of X. X, we're moving into R B of X. And what we're R A of X. And we want to do is we want to compare Y and X. Depending on the value that we get here, will determine how we handle those operations afterwards. We're going to perform an operation here, and then we're going to move this X into our A of X for our particular value. And depending on that, we will perform the rest of these actions as well. So as we move down to this and it's handling the other items here, what you see is, as I stated before, this J and O means you want to jump. Uh, if there's no overflow condition, what you're going to do is you're going to move on to line 70. If there is an overflow, then it will go ahead and handle this and output an error. So let's assume that there is no overflow. If there is, then if there is some sort of overflow issue, what this does is it moves all of these numbers into specific registers to handle that overflow. But if there's not, then you're moving on to this at position 70. And you want to do items for 119. Once you get to 70, you basically go out and looks like put some things into the RBP and eventually leave the program. So 70, if there's an error, if there's an overflow, you jump from 70, you store this guy into this, you jump down to line 1280, which is right here. You move some other things around, and then eventually you exit the program. But we're going to assume that there was not an overflow and that these numbers are correct. And if that be the case, meaning that these are right, um, the options we're going to perform are loading this into the effective memory address for our A of X. You're going to move our A of X, which we have just changed here. That was Y. You're going to move our A of X or Y into the previous position of you're going to move Y into the previous position of X, excuse me. And then you're going to do everything that you need to do to kind of complete the program. All right, that is the end of the lecture for today. Oh, no, it's not. I'm sorry. I'm sorry. This is not the end of the lecture. So this is one portion of it. I do want to show you guys one more thing as well. As you go down here, you'll see kind of some of the main functions here too, the operations for the main function, and then some additional sub things here. Let's get out of this because the last thing I want to show you guys is something that you want to use in your bomb lab, and that is what if we wanted to get a list of all the objects within our code. You can do that by doing this object dump to your obj dump will allow you to give you the function and the address information for your file. This should also be run with the um this should also be run on the executable. All right, and notice what we have here. It's giving us the address information here. It's giving you the data in hexadecimal, and then kind of what's happening. And you'll notice that on the left side, on the right side, is where we have our commands, right? So this is our main. Let's go up to the absolute diff here. And you'll see it's very similar to what we were looking at previously. The only difference is that it's giving you a little bit more of information in terms of the memory address and all of that. But look at this. You're pushing stuff out from the stack, meaning I am reserving this information so I have something to write to, right? I am So the first thing I'm gonna do is I'm gonna push and leave, give create space so that I can have something to store this data. Then I'm gonna move one of my operands into the address I took out. I'm going to create space for the other information that I have here. or I'm going to take out a register for that, and I'm going to keep on taking this information out so that I have space. And then here is where you're going to declare your variables, X and Y, right? Which you have taken out for this. So I took out two things. I took out, um, or I pushed into the stack these two addresses, RBP, two registers, excuse me, RBP and RSP. I also pushed out this RBX. Now I want to take a portion of this out because I want to use this for um, the the addresses that I want for the information that I want to store. So in RSP or in RBP, which was up here, I'm storing my X value here at 28, and I'm storing my Y value here at 30. Then I want to move that X value into RA of X. You know what register that is. Once I move it into RA of X, what I want to do is I want to compare my X and Y. That's what this item is doing. I'm going to compare my X and Y. Then once I compare it, if X is greater than Y, I'm going to jump to line 1255. And similar to GDB, it's listed by the value. That means I would jump down here. And once I jump down here, I'm moving Y into my output stage. And what I'm going to do is I'm going to subtract Y from X. I'm going to subtract X from Y. And notice how we have this similar code here is you're only if you have some sort of overflow error, you're gonna jump to uh 046. What the 124. Oh, you're gonna jump to 124F, which is right here, that says, hey, I have some sort of error. All right, but the first thing you're gonna do is you're gonna compare it. If you're good, you're gonna subtract it, and you're gonna move that into your output register. Okay, if you do not have an overflow, you're gonna perform this. You're gonna have so our first condition said, hey, yes, um, X is greater than Y. I can go ahead and subtract that. Our second condition is it's not greater. So what then I do is I move Y into my RD of X, and I subtract X from Y. And that's the condition we have here. And then I move this. Once I perform those all of those operations, looks like you're going to move this into your output register. All right, so now that we have gone through that a little bit, the last item, last but not least, is if you wanted to get just the symbols for the file. So we just saw the assembly language, right, that you can get from this object jump.d. If you want to get the symbols, you can do that through object ob dump, and then you change this to t. So let's take a look at what that outputs. These will give you all the symbols that are associated with your particular thing. ABS has an action been completed, a text, all of these that you'll see kind of in some of the labeling options. Okay, that's all I have for you guys today. Um, we'll do a little bit more of this next week, and try to gain a better understanding of it. Your bomb lab has been released, so you guys should start on that sooner rather than later, because it's a little bit of an intense assignment. So the earlier you start, the better. other than that, if you guys have questions, you can feel free to stop by my office hours, and I look forward to lecturing you guys again next week.